The sinus integralis function SI of x is important to electrical engineers. It's defined as the antiderivative of sin x over x that satisfies SI of 0 equals 0. Find the Maclaurin series for SI of x. And just so we can rewrite this a little bit, SI of x is the antiderivative, or the indefinite integral, of sin of x over x. And so we need to find the Maclaurin series for this. Let's use the heredity principle and start off with sin of x, which is a related function whose Taylor series we know. The Taylor series for sin of x is equal to 1 over 1 factorial, or just 1x, minus 1 over 3 factorial x cubed, plus 1 over 5 factorial x to the 5th, minus 1 over 7 factorial x to the 7th, plus 1 over 9 factorial x to the 9th, and on down the line with this pattern repeating. Now, to get the Taylor series for sin x over x, we could just divide both sides by x and write out the series we get from that. So we're going to have the function sin of x over x has the Taylor series x divided by x is 1, minus 1 over 3 factorial times x cubed divided by x, or x squared, plus 1 over 5 factorial times x to the 5 divided by x, or x to the 4th, minus 1 over 7 factorial times x to the 6th, plus 1 over 9 factorial times x to the 8th, and on down the line. So now we have the Taylor series for sin x over x. So we can integrate both sides of this sort of pseudo equation. On the left-hand side, the integral of sin x over x is SI of x. And on the right-hand side, if we integrate term by term, we're going to get x minus 1 over 3 factorial, the antiderivative of x squared, is x cubed times 1/3, plus 1 over 5 factorial, the antiderivative of x to the 4th, is x to the 5th divided by 5, minus 1 over 7 factorial, the antiderivative here is x to the 7 over 7, plus 1 over 9 factorial times, again, x to the 9 over 9, and on down the line. But don't forget, this is an indefinite integral. There's always a plus c, and in a Taylor series, it's traditional to write it up here. Now, what is this plus c? Well, the first term in any Taylor series is just the function evaluated at the center, and we know that SI of 0 is defined to be 0, so we can replace c by 0. And we would have this series right here. Let's clean it up. We have x minus 1 over 3 factorial times 3 times x cubed, plus 1 over 5 factorial times 5, x to the 5th, minus 1 over 7 factorial times 7, x to the 7, plus 1 over 9 factorial times 9, x to the 9, and minus on down the line. Since this is an easy to follow pattern, that's good enough for us. Here we have the Maclaurin series for the SI function.